I love math. Do you? Well, if you do, you should live by the math commandment that states, "Thou shalt do unto one side of the equation what thou doest to the other."
All right, let's go over this Module 1 practice test. Let's go over question number 1. Which is the graphs of f of x equal to x squared plus 4x plus 2? Remember, if you're getting confused with this f of x language, just write a y there. And make sure there is a number in front of all of these, because that can help us identify the a, b's, and c's. So this is standard form, ax squared plus bx plus c. If you want to know what standard form is, it basically has no parentheses. What's the difference between standard form and the other forms? There's no parentheses. And here I can identify the numbers in front. Numbers in front are called coefficients. So a is 1, b is 4, and c is 2. Now, standard form tells us a couple of things very quickly. When a is positive, which it is, it opens up, right? Positive people smile or open up. So I'm going to cross off all the graphs that have opening down, or concave down is a fancy way of saying it. The c value is the y-intercept. The c value is the y-intercept. Why is that the case? Because if you, you'll see, watch. So I write c equals 2, and here or here. Okay, that did not help us. So what kind of did? The reason why c value is the y-intercept, because here it has the order pair.
We can't see anything.
Oh, thank you, thank you. Let's try that again. Let me see. Can you guys see now?
Much better.
Oh, thank you. Let's start again. If you get confused with f of x, just change this f of x to a y. And then you want to have numbers in front. Numbers in front. So have 1, 4, and 2 here. And then here in light blue, you have the standard form, ax squared plus bx plus c. Now, standard form has no parentheses. There are no parentheses there in light blue. The other forms, vertex form and factor form, have parentheses. If you want a visual, like a handheld one, I have a foldable video. If I have time, I'll try to find them for you guys leave for class. If not, then you can email me or you can search on my YouTube channel. It's a foldable that shows the difference between standard form, factored form, and vertex form, which you'll need for your project next week. Okay, so there I circled the coefficients, or just the numbers in front. So a is 1. A is 1 here. B is 4. And C is 2. So there I wrote A is 1, B is 4, C is 2. And A here, that 1 there, is positive because there is no negative number in front. And the trick is positive people smile. Positive people smile. So that's why I put an X there at C and D, because those are kind of like sad faces. Does that make sense? Okay. The other quick clue is that the C value, C equals 2, represents the y-intercept. And I was about to explain, why does that represent a C value of 2? Well, if you put an order pair here, the order pair is 0 on the x-axis, 2 on the y-axis. So the order pair is 0, 2. So if you put in x equals 0 into this equation here, you'll get 0 here. 0 times 0 is 0. 4 times 0 is 0. 0 plus 0 plus 2 is just 2. So the C value is the y-intercept. Now that didn't help us because both A and B have not been eliminated. So the last thing I'm going to choose is the axis of symmetry. Axis of symmetry. And that formula is x equals negative b all over 2a. And what I'm going to do is I'm going to put in 1 for the a value and 4 for the b value. And what I'm going to do is here is just simplify. I'm going to get 4 over 2, and 4 divided by 2 is just positive 2, and you have a negative in front, so x equals negative 2. That means if I go to the x-axis and locate 2, this blue line, dotted line that I'm drawing, is the axis of symmetry. Does that fold the parabola or the taco in half? It does, and that's why the answer is A. You'll notice if I put the axis of symmetry over here, this does not fold the parabola or U-shaped graph in half. That was question number 1. Okay, question number 2, the average rate of change for the function f of x equals 4x squared plus 3x on the interval of 1 to 5. This interval is not an order pair. It is not an order pair. You kind of need, we'll just separate it by color. So this is one x value. And this is the second x value. And what I'm going to do is for the first x value here, I'm going to put it back into my function. So every time I see x, I am writing 1. And you'll see that by my parentheses, which you should have on your work. Don't worry about the left side, the f of 1. Don't worry about that. Just put in 1 in for x. And let's simplify. 4 times 1 is 4. Oops, we've got the exponent. So PEMDAS, let's write that. It's amazing. Also at my church, someone said, hey, Mr. Ng, I need help. I need to pass an Algebra 2 test and become an electrician. I said, great. This right here would probably help this person quite a bit. And what I'm writing here is you simplify going down. So we're going to do parentheses or exponents first. So that would be 1 squared, which is 1. And 4 times 1 is 4. 3 times 1 is 3. And 4 plus 3 is 7. So you have f of 1 equals 7. What does that mean? It just means that your output, your answer is 7. 1, 7 is the answer I'm looking for. We're going to do the same thing over here in the light blue side. I'm just going to call this one x2. And we're going to do the same thing. We're going to put it in for every x value. You see that? 5 squared plus 3 times 5. Okay, should I multiply or do the exponents? Well, that's why we have order of operations PEMDAS. PEMDAS says to do parentheses and exponents first. So this would be 4 times 5 squared. 5 squared is 5 times 5, which is 25. And this is 15. Now I can just multiply. Get 115. What does that mean? The answer is 115. So back in my notes, I would kind of say evaluate separately. That's what we just did. And then the second thing we need to do is actually use the slope formula. The slope formula is m. M is, I know, does not start with s. It's actually a French word for slope or mountain. It is y2 minus y1 over x2 minus x1. It is okay if you flipped it and you said something like this, y1 minus y2 over x1 minus x2. And you're asking, where do I get these x1s, x2s from? Well, you get it back up here. This one is going to be y1, x1, y1, x2, y2. All right, so let's use some color coding here. x1 is going to be 1. y1, whoops. y1 is 7. So I'm going to write a 7 here. And let's put those in parentheses because a lot of students will make some mistakes here. My x2 value is here, which is 5. So x2 goes in the bottom. And y2 goes here. So that'd be 115. And then I just evaluate this. So I get 115 minus 7, which will be 108 over 4. 4 goes into 10 twice, and then 4 goes into 28 7 times. So my slope is 27. I'm going to double box this to kind of show you that's my final answer. To give you guys a quick visual of what's happening here, we have a parabola, factor out an x, 4x plus 3, negative, something like this. And what we're doing is from 1 to 5, where x equals 1, and where x equals 5, we're trying to find the slope of this pink line here. And that's why it's such a huge number. It's 27. Number 3, use the graph to find all these solutions. Not very dark. Let's see. Solutions are basically anything that crosses the x-axis. Other words for solutions are x-intercepts. You'll see the word zeros, or also the words roots. So these are synonyms for anything that crosses that orange line. So they want to know basically, if I highlighted them, this point and this point. Some other features about this quadratic equation that I want to point out is that it's in standard form. Standard form. How do I know it's in standard form? There are no parentheses. There are no parentheses. I have a video, see if I can find it. It's called a quadratic foldable, and it's pretty neat. Kind of summarizes all the big ideas. Let's see. Mr. Nothing, quadratic foldable. There you are. Should have made you guys do it this year, but basically it summarizes the 3 forms that you've already learned. Standard form with no parentheses. One set of parentheses is vertex form, and then there's factored form that has the 2 sets of parentheses. So you can watch that video later. Okay, so now that you know you're in standard form, there's no parentheses. That's the ABCs. And I just wanted to point out the ABCs because it verifies this graph. What does it verify? Well, number 1, A is 1. And what that means is it opens, it's positive, and positive people smile. And that verifies that the graph is opening up, or a fancy word is to say that it's concave up. The other one I wanted to point out was that the C value is -3. And you'll see that in our y-intercept. Okay, so that was just a quick review of standard form, what they gave us. Now, obviously, this problem you can't factor. How do I know that? If you try the Xbox method, you'll notice that there are no two numbers that multiply to be -3 but add to be +1. You'll also know that these are called irrational. They're irrational because they're not whole numbers. And you can kind of see that in your selections below. Select all the pairs of consecutive integers. Consecutive means next to. So 1 and 2 is consecutive numbers. You look all the numbers below, -3, -2. They're next to each other, between the roots that are located. So we talked about roots are basically where it's crossing, right? So if I look over here, this is -1, -2, -3. So it's between -3 and -2. So that would be choice A. Now it does say select all, so that means there's multiple. And then the one over here, well, this is 0, this is +1, and this is +2. So that would be choice E. Okay, so in this problem, we found where the roots are. They're between 1 and 2 and -3 and -2. Let's try question number 4. In question number 4, you're tempted to just put them underneath the same house or radical sign. And we actually have to evaluate those separately. So this is where pirates come into play, because pirates say, who wants to say it? I'm not going to go over the problem. Someone has to say it. What do pirates say?
Pirates say I.
Aye! There you go, Angel. Love the historical reference. Aye! Now, this is a big idea. That's my fancy I here. I is the square root of -1. I is equal to the square root of -1. So the square root of -25, the factors are -1 times 5 times 5. Don't be confused, that is a multiplication sign. And like I said, you're kind of evaluating these two separately. -1 times 9 times 9. Now, a student emailed me asking, Mr. Ng, when you're simplifying radicals, are you just looking for pairs for them to come out? And yes, that is true. You're looking just for pairs. So here's a pair. Remember my story, it's a scary neighborhood. The street sign says there are 2. You need 2 identical kind of people of the same age. You need people of the same size in order to come out of this house into the scary neighborhood. But when you come outside of the house, you're so close together, like you're so scared, right? When you look from far away, it's just one number. So here I have 5. And we just talked about square root of -1 is equal to I. So here's the square root of -1. We're going to write I. Square root of -25 is 5I. Square root of -25 is 5I. Let's go over here to the right side and do the same thing. You have a pair that can come out. And then you have the square root of -1, which is I. So I have 5I times 9I. And this will become, you just multiply the constants. So you have 45. And I times I is I squared. Okay, there's 2 ways of simplifying I squared now. You can look back your notes and we just made a chart. I squared is equal to -1. I squared is equal to -1. Now, let's just say that's too complicated for you or don't want to memorize it. I times I is just I squared, right? And you have square root of -1, square root of -1. And when you're multiplying, you can put them in the same house. Does that make sense? And well, we just did the same thing. You have a pair. So those can come out. So you have 45 times -1, which will be -45. So -45 is your answer for number 4.
Okay, in quadratics, there is one method that will always work. Who's got it? There's actually two methods of the 5. Anybody? Feel free to put it in chat or unmute. Come on, you guys know it. We'll make you take the class again. Come on. What are 2 ways of solving with quadratics that will work? And this always works. There's one you may have tried and you realize it doesn't work. Quadratic formula and completing the square. Quadratic formula and completing the square would have worked on this problem. Methods that don't always work are the square root method, which is like completing the square, which I'll show you guys, and factoring. Factoring does not work on this one. So find this pen really quickly. Let me show you guys why factoring does not work. X squared plus 0x plus 16. The reason why I put a 0x in there is because a common mistake is 16 is not the b value. Let me say that again. 16 is not the b value. Write standard form right above it, and you'll see why 16 is not the b value. The c value is always just, has no x's. The b value is always in front of the x, or we call it the coefficient. And a is always in front of x squared. Does that make sense? And you kind of need this idea for second semester. We're going to talk about polynomials quite a bit. So let's just say you try to factor this. A times c is 16, and your b value is 0. There are no 2 numbers that multiply to be 16 and add to be 0 on the real number solution. Does anyone know what I could put in there? Super critical thinking. I haven't taught you guys this method, but I'm showing it to you now. Anybody in the chat? All right, take a look at this. 4i and negative 4i. If you add those together, this will equal 0. But if you multiply those together, you will get negative 16i squared. And then I squared is negative 1. So you get 16 as your answer. How can you use those? Well, so I'm using what? Factoring. You can put in here x plus 4i and x minus 4i. So that's just one way of frying or cooking the potato. Another method you could have used was completing the square, or square root method. CTS, completing the square. And this one's super fast, probably faster than factoring. And it only works in this problem. I just moved 16 to the other side. Your c value is now isolated, so square root method only works when you have an a and a c. I have x squared equals negative 16. To get rid of the power of 2, you take the square root of both sides. I'm going to put a 2 here so you recognize that it's an invisible number there. So these will cancel, and you're left with x. Don't forget to have a plus or minus. So every time you solve an equation with a square root here, you must add the plus or minus. The factors of negative 16 are what we just did previously, negative 1 times 4 times 4. So we have the 4 that comes out, and the square root of negative 1, which is just I. So x equals plus or minus 4i. So you'll see that from factoring. Factoring, you would just set each of these equal to 0 and solve. And you would get the same thing. So our two answers, let's highlight this. We're running out of time, so you could have used the quadratic formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. That one always works. I got stuck when I was taking calculus in high school, and I kept using the quadratic formula. It's long, it's tedious, lots of possibilities of mistakes, but it works.
All right, let's go over question number 6. Which of the following expressions is the factored form? We didn't spend, we'll spend more time on this in the next module, but factored form is essentially looks like this. So there's two ways that you can kind of get the answer here. Let's say you want to use something that we've done in class. And this is your A, B, and C. A times C is 25, B value is 0. Normally you wouldn't be able to think of something, but if you did something like 5i and negative 5i. We did that in the last problem. If you multiply those, you'll get negative 25i squared. I squared is negative 1, so that would equal 25. So then you can put in 5i and negative 5i. And of course that would just become 1 plus and 1 is minus. Which would be choice C. A second way of getting the answer, let me use white here, is you just solve this by square root method. So you subtract 25, take the square root, you're going to have x equals plus or minus 5i. And that's the same plus or minus 5i I did here in pink. Number 7, what is the voltage of an electronic circuit with a current of C, with a current C, which is 2 minus J, and an impedance I of 3 plus 2J? Use the formula V equals CL. Okay, so C is 2 minus J. And impedance is 3 plus 2J. So what is the voltage is our question. So what is V? So here I'm just going to use our box or area model to multiply. And once we get to the J's, you could just take it out and put in I's. So we're just going to multiply first, and then we're going to add or combine like terms inside the box. 2 times 3 is 6. 2 times 2j is 4j. 3 times negative j is negative 3j. And negative j times positive 2j is negative 2j squared. So just multiply. Now we're going to add. I'll just put it out here so you can kind of see that. And then we'll just combine like terms. These two are like terms, so I have negative 2j squared plus j plus 6. You'll notice that that's not one of our answers because I said that you might want to change this into i's. And then right here, I squared equals negative 1. So negative 2 plus I plus 6, so that becomes negative 2 plus I plus 6, and these are like terms, so you'll get 4 plus I or something like that is our answer. Let's take a look at what we got, and that would be choice C, kind of like that one that says 4 plus J. Question number 8, factor and solve the quadratic equation. So I have A, B, and C. Remember the trick, let me summarize the trick. When A is equal to 1, then you just have to use the X. Let's do that in orange. When your A is greater than 1, you have to use both the X and the box. X and the box. Let me show you how that works. A times C is negative 20. Your B value is 8. Two numbers, I don't know, 2 and 10? 2 and 10 works. So 2 and 10. And I want those to be, one of those to be negative. So my answer is just going to be x minus 2, this is the factored form, x plus 10. And that'll be choice B. Now, if you did put this in, remember x squared, whoops, x squared always goes in the top left, the C value goes in the bottom right, and then your two numbers. And greatest common factor, greatest common factor, greatest common factor, and greatest common factor. And you'll see it's x plus 10, x minus 10. And then the solutions are just setting that equal to 0. So taking this, and now I'm going to set each of these equal to 0. So that would be choice negative 10 and positive 2. So B, A, B. All right, a lawn in the Park City is 50 feet long and 30 feet wide. A path with a width of X will be placed around the park. The city has enough paving material to cover a path with an area of 900 square feet. How wide should the path be to use all of the paving material? Okay, in these problems, I call this the I'm going to call this the shaded region. So I have two things. Let's see if I can color code this. I have this blue one, which I'm going to call blue is big. This orange one in the middle, we're going to call small. So follow my, hopefully, conceptual big is equal to the small plus the shaded. And what we're trying to do is find the shaded, so if I subtract small from both sides, my formula is going to be the big minus the small equals the shaded. Okay? So for the big, let's do all my work in light blue. This length, let's see if I can move this, is x, 30, and x. So area is length times width. Let's call this one length. So that you're adding those, right? X plus 30 plus x would give me 2x plus 30. And we'll call this one width. So that would be x, 50, and x. So that would give me 2x plus 50. Okay. I'll just multiply this using my box. So I get 4x squared, 100x, 60x, and 1500. So the area of the big, it's called, 4x squared plus 160x plus 1500. Okay. Okay, now let's get the area of the small, which is in orange. That one's going to be super easy because it's just 30 times 50. Area of the small is length times width, and that was 50 by 30. So that would be 1500. The area of the small is 1500. Okay, so let's put that in our formula now. The blue is my big, and I'm going to write that right there. 4x squared plus 160x plus 1500. And then the small, we're going to subtract it. And the shaded region we want to be less than 900. Okay, so if you add these, you're just going to get this. 4x squared plus 160x equals 900. And to solve quadratics, you're just going to set it equal to 0. So I have 4x squared plus 160x minus 900 equals 0. Okay, I'm going to factor out a 4 to make this number smaller. 4 goes into 9 2 times. 4 goes into 10 twice. And 4 goes into 20 5 times. And then, if I factor this one, um, 25 goes in 9 times. 45, there are 5 of them. So that is my answer there. Okay, then I just solve it by setting it equal to 0. That's an arrow. So that can't happen. So x equals 5 and negative 45. But, you know, you can't put in negative 45 feet into your equation. So if you put in 5 in here, watch what would happen. If you expand it 5 feet each direction, this would allow you to use the 900. So the shaded region is, let's see, put this in pink. This is all what we can do for the shaded region. Because if you put 5 back in there, it'll give you 900. So the answer is 5. Okay, number 10. Use the square root property to find the solutions. Okay, that means that this side is factorable. So A, B, and C. Whoops, 36. A, B, C. So 36. Negative 12. My two numbers are negative 6 and negative 6. And all I have to do is take the square root of both sides. You're going to get x minus 6 equals plus or minus 8. And then if you add 6, x equals 6 plus or minus 8. So 6 plus 8 is 14, and 6 minus 8 is negative 2. So that would be 14 and negative 2. What value of c makes it a perfect square? So remember, perfect square is half of the b value squared. So there's the b value is 36. So that would give me 18 squared. 4 extra 6, 144, 0, 8, 1. Did I do that right? 324. So that would be B. Solve by completing the square. So this one, notice how it has the equal sign here. Use the same formula, b over 2 squared. This is your a, b, and if you move the c over, it would be a negative 1, but I don't need that really. So b is negative 8. Just keep the theme orange over here. I said orange. Negative 4 squared, which is 16. Okay, so if c is 16, pay attention. On this part, I'm going to do plus 16 on this side and plus 16 on that side. Because what that does is it doesn't change the equation if both sides are, I call the addition property of equality. And the reason why we did that is so that we could factor this part. A times c is 16, b value is negative 8. My two numbers are negative 4 and negative 4. Take the square root. Don't forget the plus or minus. And then add 4. You're going to have x equals 4 plus or minus the square root of 17. And no multiple choice, so that's your answer. Double check that one. Yep. All right, number 13. Use the quadratic formula. Set equal to 0, that's good. A, B, C. Sing the song, guys. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, a is 5. So every a value and then b is 3. Notice how I didn't highlight the negative sign there. And c value is negative 1. X equals 3 plus or minus the square root of 3 squared minus 4 times 5 times negative 1. All over 2 times 5. Let's go ahead and simplify that. X equals negative 3 plus or minus 9. Pay attention how I do this one. Negative 4 times 5 is negative 20, and negative 20 times negative 1 is positive 20. All over 10. X equals negative 3 plus or minus the square root of 29 over 10. Okay, let's take a look at that one. And choice A is your answer. Number 14. Use a discriminant to describe the number of solutions for the equation. Remember, discriminant is what's in the inside. So if I just had to, discriminant is right here. discriminant. It's the inside part. Okay? So, A, B, and C, make sure it's set equal to 0 there. So B is 5, A is 2, and C is negative 12. And we're comparing it to 0. 25, negative 8, negative times negative is positive, and I believe that'll be 96. So then you have 121 is greater than 0. Okay, pay attention. So, okay, now this one is a perfect square. And when it's a perfect square, then you actually have two reals. And I want to prove that to you. 2x squared plus 5x minus 12. 2, 5, negative 12. 2, 5, negative 12. 2, 5, negative 12. And you can see that, again, the reason why they are called rational is because they end. You see it just says 1.5, and then, whoops, negative 4, negative 4.0. It's rational, it ends. Irrational means it would have been like 1.46375, bunch of numbers, right? Okay, number 15. Arrow is launched upwards. The height of the arrow in meters after t seconds can be modeled by the function. After how many seconds? So basically, I know it doesn't say it, but they're running what the letter t is. With arrow when it first reaches an altitude of 100. Okay, so this is how you know, right? You can't see that. A, B, C. C is starting at 1. So this is what your is looking like, okay? So h of t, okay, I'm going to change my t's to capitals so I don't get confused with my plus signs. And then the height that I want is 100. And everything else is the same. And then I'm going to set it equal to 0 because that's how you solve quadratics. Okay, from here you could you can factor out. I don't think it's going to be nice. Negative 99 divided by 4.9. Yeah, it's going to be a bad number. So you could just put this whole number in. Negative 4.9t negative 4.9x squared plus 100x minus 99. Okay, so I got two values, 1.04, 1.04, and 1936. So basically what that means is at that time, right, this is x-axis is time, and then the y-axis is height. So after 1.4 seconds, it's at 100, and then it travels back down to that spot again at 19.36. Blah. And then your only choice when it first reaches. So they're talking about the first time, which is right here. So that'd be this one. Pencil turn off on me. So not that one. Okay. Number 16. Which of these graphs represents the solution set? Okay, so you could just you can factor it. Let's see if it factors. Right? And so I have x minus 3 and x plus 1, and then you set it is equal to 0, you're going to have 3 and negative 1. So we already knew that because all of them are at 3, negative 1. Do you see this? Okay, so a couple of things you need to first note is this one is less than. Okay, so less than means that this is going to be a shaded line on the solution. Shaded line on the solution. So it's not going to be B or D. It has to be either A or C. Now I'm going to use my test points. Okay? And the easiest one to test is 0. So let's use pink. I'm testing 0. If I put in 0 here, and the order pair is 0, 0, so x is 0, y is 0. I'm just testing this one. It's not the... And let's see if it's true. If it's true, then we shade it. So is 0 smaller than negative 3? This would be false. So don't shade 0, 0. Which graph does not have 0, 0 shaded? Well, obviously, that would be A. Okay, because C is shaded in there. So they're saying that 0, 0 would have been a solution, but it's not. Number 17, what is the solution set of negative x squared plus 2x greater than or equal to 0? I'm just going to factor out a negative x. Just going to solve it like regular. Set it equal to 0. X is equal to 0 and x is equal to 2. So 0 and 2. I know the a value is negative, so it's going down. Do some magic, get to move it. Is that cool? Okay. And now I want to test points outside of these numbers. So let's just say you put in negative 1. So I'm testing negative 1 over here in the orange area. And that has to be greater than or equal to 0. So negative 1 squared is 1, negative 1, negative 2, negative 3 is greater than or equal to 0. This is false. So no shade. Okay, so that means I'm going to assume that it's going to be here inside. But let's test it. Negative, oh, that's a positive 1, squared plus 2 times 1 greater than or equal to 0. So 1 squared is 1, negative 1 plus 2, so that 1 means 1 greater than 1 is greater than or equal to 0. This is true. So the solution is inside or between 0 and 2. Okay, and then you can do it later, but this is going to be false out here. Okay, so my solution is between 0 and 2, and then your choices are between A and B. Well, it says equals 2. So if I put 0 in there, that would be a bracket. So my answer for number 17 is A. Number 17 is A. All right, last page. Video games. Developer determines that the profit in thousands from a new video game can be modeled by the function p of x equals that, where x is the price of the game. The game will be profitable if x is greater than or equal to 0. To make the game profitable, it should be at least and no more than what? Okay, so all we have to do is just solve it. You know, quick visual. Pretty bad game. All we have to do is just negative 2,000. So and basically we're finding this point and that point. Okay? All right, let's see if it can be nice and easy to us. Negative x squared plus 130x minus 2,000. Let's factor out the negative 2, so I get negative 15, negative 65x, and positive 1,000. All right, I need two numbers that multiply to be 1,000, but those same two numbers add to be 65. So here's my trick. $1,000 divided by x, and then I want this table to count by 5. So second, and then I want it to change by 5s. Okay, then you're looking for two whole numbers. So 2 times 5 is 1,000, but if you subtract them, it does not equal the number we wanted, which was 65. And maybe I shouldn't have to count by ones. 1. Nope. Table. Okay, right there. 25 and 40. 25 and 40. $25 and 40. Okay. And then if you set this equal to 0, 0 can never equal negative 2, right? So you don't have to worry about the negative 2. And that one's going to be 40. So our two numbers are going to be 25 and 40. Okay, number 19, solve this system. I think substitution is one of the easiest one. Elimination would be easy. I'll show you guys both. So method number 1, I'm going to do, I think is the easiest one, is elimination. And I'm going to do elimination by taking the first equation, so I'm just going to repeat these. And multiplying one of these equations by both sides by negative 1. So this will give me negative 2x minus y minus 2. And what you're doing here is you're just adding the two equations together. Those are not like terms, pay attention. So x squared minus 2x, but this is what I wanted, the y's to go away. Equals 8, and if you subtract it to the other side, you're going to get minus 8 equals 0. I did that because I want quadratic set equal to 0 to solve. Let's go for the home run. Let's see if we can just factor that. Two numbers that multiply be negative 8 and add to be negative 2, so 4 and 2, so minus 4, positive 2, and then if you set them equal to 0, you will get 4 and negative 2. Okay, so then what you're going to do here is you're going to put in 4. You could just, here, x equals 4. So 2 times 4 is 10, and then subtract the 10 from both sides, you'll get y equals negative 8. So for negative 8. Okay. What? X equals 4. If I put in 4, oh, duh, just can't add. So that would become 8 plus y equals 2, and then subtract 8, y equals negative 6. So I was yelling at myself. Okay, so that's one solution. The second solution is if you just take the same number, now negative 2, put it back in there. So 2 times negative 2 plus y equals 6. So negative 2 comma 6 is our other solution. So those are the two answers. How would you do the same problem, getting the same answers, if you did a method called substitution? I can't spell. Okay, so x squared plus y equals 10, and you have 2x plus y equals 2. I'm going to subtract 2x, and now you're going to get y equals 2 minus 2x. I'm going to take that and put it into this second one right here. See this? So that would become 2 minus 2x. So x, why does it keep giving me black? X squared plus, so you'll do the same thing. Subtract 10, and then you'll recognize that you have the same thing as you have on the previous problem, and then you can solve it. But it's just kind of like choose your own adventure. In the beginning, it's very different. Okay? Okay, number 20. What are the solutions of a system? Select all that apply. So if you guys notice something, I didn't even test the discriminant. You can put the discriminant in number 19. You can graph them, and you can see how many solutions there are. If you're thinking about which one to use, substitution or elimination in this problem, I already know that y is solved for, so I would use substitution. I'm going to use substitution. The reason why I'm using substitution is I see in these two equations, the second one's already solved for. What does that mean? Every time I see y, I'm going to write x squared minus 4. I see a y right here, so I'm going to write x squared minus 4. And the other side is everything else is the same. So instead of writing y, right, the original problem was this, on the first equation, so I'm basically putting the second equation into the first equation. And then you can just solve for it. Like terms, 4x squared, add the 4 to the other side, divide by 4, and take the square root, x equals plus or minus 3. Okay, so all the x values have to be 3. So no, 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 no. Does it make sense? So let's test it. I'm probably going to use this y equals x squared minus 4. And let's test one that is positive. So I got 5. Basically, it means I put in 3 for x and I got 5 for y. So 3, 5 is one of my answers. Let's test the other one. This one I'll do -3. So -3 for x, and then my y value was 5. -3, 5. So that would be choice E. So notice how I did both of those, and those are your solutions. Hopefully that was helpful. See you guys later. Bye.
24 hours in a day, and I get to do math, hey hooray. Y equals mx plus b with Mr. Ng, we're making history. Pythagoras, Euclid, and Gauss, learn the math and you'll become the boss.